Good morning everybody. I am Dr. Kumar Khan and welcome back to my class once again. Today I am going to give you a demonstration on the experiment with microprocessor. I will be using Intel 8085 microprocessor for my demonstration. I will start with a brief discussion on the structure and functioning of a microprocessor, and then I'll show you how to write a program and how to execute the program to get the desired result. So let's go to the computer screen for my lecture and for my programming class. Let's start for that.
Microprocessor. A microprocessor contains the entire CPU of a computer on a single IC chip. When a microprocessor is connected to a memory and provided with input and output devices, it becomes a computer. So, the microprocessor is the brain of a computer, and a microprocessor can be programmed with a series of instructions to perform a specified functions on the given data. And this is the block diagram of a microprocessor based system. I have a microprocessor which acts as a CPU, and then I have the memory unit and the input output ports, and I have the control bus, data bus, and address bus. So this gives a block diagram of a microprocessor based system. And today I am going to use Intel 8085 microprocessor. It is simple and its basic principles are used in more advanced microprocessors. And this particular microprocessor is specially used for giving training to the students. And this is the pin configuration of Intel 8085 microprocessor. It is an 8-bit NMOS microprocessor having 40 number of pins. So the pins are 1 to 40, and all the pin connections are written here. And here I am showing the functional block diagram of Intel 8085. It has the arithmetic logic unit, then it has accumulator, temporary registers, then 6 8-bit registers B, C, D, E, H, L, then stack pointer, program counter, incrementer, decrementer, address latch, then it has data or address bus, then it has serial input output control, then interrupt control, then internal data bus, time and control, clock generator, then it has power supply plus 5 volt and ground. And this is the picture of the trainer kit Intel 8085. As I discussed earlier, this has the input part like the keyboard we have. Then we have the display unit, that is the output part. Then this is the 8085 microprocessor IC having 40 pins. Then it has memory, ROM, RAM. Then it has time controller here, etc. And to work with a microprocessor, we need an instruction command. An instruction is a command given to the microprocessor to perform a specified operation on the given data. Like if we want to add two numbers, if we want to subtract two numbers, if we want to multiply two numbers, if we want to divide one number by another number, then we have to give the command to the microprocessor. Then only it can give the result. Therefore, a microprocessor is basically a machine for executing instructions, and the collection of instructions is known as the instruction set or the program. Each instruction for desired operation to be performed contain the following informations about the desired operations, and these are the source of operands, destinations of the result, and the next instruction address. And each instruction has two parts: operation code or op code to indicate the task to be performed, and the operand data or the address of data to be operated on. And the Intel 8085 microprocessor instructions may have three different lengths. The lengths may be of 1 byte or maybe 2 byte or 3 byte instructions. As an example, this MOVC, A is an instruction. This is 1 byte or 8-bit instruction having a hex code 4F, and this instruction is given to instruct the microprocessor to copy the contents of the accumulator A in the register C. And this 1 byte or 8-bit instruction requires only one memory location to store the data. Now we have to understand how a microprocessor works. A microprocessor can only understand instructions written in binary form known as machine language program, and the program has to know the binary code of each instructions. Therefore, this is an extremely tedious job. There is another alternative. Alternative to machine language is the assembly language, which is easy to remember. That is called mnemonics, and mnemonics are used to represent different operations. Like in the previous slide, I showed you move MOV A, C. That was the mnemonics. That represents one operation to move a certain data from one particular location to another particular location. And here once again we discuss with the example how the mnemonics are used here and how the hex codes are written. Move the contents of the B register into the accumulator A is represented by the mnemonics move MOV A, B. The program is in assembly language. The program is translated into machine language by the system. The machine language and assembly language are machine dependent languages. They are called low level languages. Machine independent languages are there, such as BASIC, Fortran, COBOL, C, C++, etc. These languages are called high level languages. A high level language is translated into machine language by a device called a compiler, and the corresponding program is called the compiler program in the memory. Now we will learn how to write programming in Intel 8085 microprocessor. So the first problem I have chosen addition of two hexadecimal numbers and store the result in a specified memory location. So the necessary steps to be taken to solve this problem or to write the program for this particular problem. Step 1 will be load the two numbers to be added in the register, and the step 2 is add the numbers, and step 3 is the storing the result in the specified memory location. And in a flowchart we can summarize the problem like this or summarize the program writing like this. We have to start at some point, then we have to load the hex numbers, then we have to add the numbers, then we have to store the result, and then the program will end. And here we have summarized the mnemonics to be used and the corresponding hex code and in the middle column I have given the comments to all the mnemonics. Like the first mnemonics MBIA39H. Purpose of this mnemonics is to load the register A with number 39 in hexadecimal. And the second mnemonics is MBIB56H. That means we have to load the register B with hexadecimal number 56. And then third mnemonics is add B. This, what does it do? This mnemonics add the contents of A and B and save the sum in the register A. And finally, the mnemonics STAE150H. What does it do? This particular mnemonics is to store the accumulator contents in the memory location E150 in hexadecimal in E150H. And at the end, HLT, that is the end of the program. And the right vertical column, the hex codes are corresponding to MBIA 39H, 3E and 39. MBIB 56H, 06, corresponding code is 06 and 56. Add B 80, STAE150H 3250E1, and HLT corresponding hex code is 76. And here in this slide we are able to understand, as I discussed earlier, the hex code or program can be of three different lengths: 1 byte, 2 byte, 3 byte. Here we see add B has 1 byte, length of 1 byte, but MBIA39H has 2 byte length. MBIB56H has 2 byte length. Similarly, STAE150H has 3 byte length, 3250E1. Again, HLT has 1 byte length. One thing here is missing, that I'll show you in the next slide. We have no address written here. That address for each hex code is needed to write the program and to execute the program. That is very much essential. So address is a very crucial part of this microprocessor program writing. So another interesting thing is hand assembly, storing and execution of the program. We have to write the program in the microprocessor. So for that, the microprocessor is first reset, and the first memory address is chosen where the program is to be stored. Then we have to enter each hex code by using hex keys. Then the monitor program stored in the ROM or EPROM of the system converts this hex code into binary code, and the program is now executed and the memory location is checked for the result. And this is the block diagram for writing, storing and executioning of an assembly language program. So first, to write a program, we have to prepare a flowchart. Then we have to find out the appropriate mnemonics of Intel 8085 that is available in the manual or any textbook on Intel 8085 microprocessor. Then we have to find out the appropriate hex codes, hexadecimal codes for all the mnemonics. And then the monitor program, it converts the program into binary code. Then we have to execute the program and the result will come. All these steps I'll show you while writing the program in the Intel 8085 microprocessor kit. So I have taken a few examples for writing the program Intel 8085. So I have simple examples of assembly language programs. Program number 1, addition of hexadecimal numbers using direct addressing mode. And what is direct addressing? The direct addressing mode contains the concerned operand in the instruction code's address field. It requires no memory references for accessing the data. So it's a very simple and fast process. It takes less time to execute the program and getting the result is faster. So I have the example here. So I have taken in the left column the addresses. So my starting address is 2000 and then I am increasing the address 2001, 2002, 2003, 2004, 2005, 2006, 2007, 2008, 2009, 2010, 2011. So the program will be written like this. So first of all, the mnemonics or the instruction is LDA 2050H and the corresponding hex code 3A 5020. And what it does, this LDA 2050H, this basically loads the data into the register A from the memory location 2050. So we have to first keep a number in the location 2050, memory address location 2050. Then we have to move or copy the content of the register A to the register B. For that, the mnemonic or the instruction is MOVBA and the corresponding code is 47. So what does it do? It actually copies the content of A to B. And then again I am using LDA 2051H. The corresponding hex code 3A that goes to 2004, 51 that goes to 2005, 20 that goes to the address 2006. And what does it do? It loads the data into A from the memory location 2051. So I have to keep a hexadecimal number in the memory location 2051. Earlier I had kept the previous number in the memory location 2050. Now I am keeping the number at 2051 and that will load the number from 2051 to the register A. Now I have the mnemonics instruction add B. That means it performs the addition operation with the content of A. So performs A plus B and it stores the result in the register A. Then again I have another mnemonics or instruction STA2052H and the corresponding hex codes are written at 2008, 32, 2009, 52, 2010, 20. And it actually stores the content of A in the location 2052H. And then I have to say end the program. For that I have the instruction HLT and that command has the corresponding hexadecimal code 76 and that is written in the memory location, memory address 2011. Now let's do the experiment in the trainer board.
Okay, this is our 8085 trainer board. Let me first show you how the memory addresses are shown here and the corresponding data saved here. So I am resetting the whole system and then I am retrieving the memory location. So I am starting, suppose, memory location 200 and then I am checking what data is stored inside this. So it is stored DF. This is a hexadecimal number DF. And for the next number, the memory location is 2001 and here the number is 0F. Similarly 202, 7F is stored, 03 and so on. So if I change the address, then the corresponding number is shown in right part of the display. So first let me show you how to get the addition of numbers using direct addressing mode. So as I showed you in the slide, we have to first select two numbers and store the two numbers in two different memory locations. So I am choosing two numbers 3A and 8F for my problem. So the numbers are 3A and 8F and 3A is stored in the memory location 2050. So that I have to first store. So I am storing, I am first resetting, then I have to go to the memory location 2050 and then I have to save the number 3A. It is already saved 3A. Okay, and Then I have to go to 2051 here, and I have to take the number 8F. So for that I have to select these keys 8F. So done. Then I have to write the program. So for writing the program, I have to start from the memory location 2000 as I showed you in the slide. But you can select your own address. So you need not have to always choose the starting address 2000. As I have discussed in the slide, the starting address 2000. That's why here also I am showing you 200. Okay, once again I am entering 2000. Then the corresponding code will be 3A. So it should be 3A. 3A. Then next 2001, the code will be 50. Then next code will be 20. Then next code will be 47. Then next code will be 3A. Then next code will be 51. Then next code will be 20. Then next code will be 80. Then next code will be 32. Then next code will be 52. Then next code will be 20. Then next code will be 76. Then next. Then I have to reset. And now I have to once again check whether all the memory locations, the codes I have entered in all the memory locations are properly saved in the memory or not. So I am starting from 200. What is there? 3A as I entered, then 50, then 20, then 47, then 3A, then 51, then 20, then 80, then 32, then 52, then 20, then 76. Okay, and then I have to check 2050 and 2051. So for that I have to go to the address 2050, and what is there? 3A. Then what is there? 2051, it should be 8F. 8F. So then I have to reset. Then I have to check it once again. 2050, 3A. Then 2051, 8F. Okay. So I have entered my program. Program is written and it is entered into the microprocessor. Now I have to execute the program so that it works as per the instruction and gives me the result. To execute the program, I have to first reset, then I have to say go. Then I have to go to the starting address, that was 2000. Then I have to say this E comes. E means executed. So the program execution is over. So after executioning the program, what it has done? It has added the two numbers, that was 3A and 8F. And what will be the result? Result will be C9. And where the result will be stored? The result will be stored at 2050 memory address. So now I have to go to the memory address to check whether I am getting the result properly. So now again I have to reset. Then I have to go to the memory address 2052. Then what will be the result? C9. So you can also check, if you add two hexadecimal number 8F and 3A, then you get the result C9. So it is also showing. So my first problem is done. Next, let's go back to the slide once again.
Now we'll go to the second problem. Second problem is subtraction of two hexadecimal numbers using direct addressing mode. So here is the program. So it's very much similar to the earlier one. There is only difference is this mnemonics or instruction. Here instead of add we are using SUBB. This performs A minus B operation and it stores the result in register E. So rest of the parts are same. It has the address like before, hex codes like before, and all the comments are written for each instruction. And for this also, let's do the experiment in the trainer board.
Now we will be writing the program for the second problem, that was subtraction of two hexadecimal number using direct addressing mode. So we will be using the same numbers. The numbers are 8F and 3A. As 8F is bigger than 3A, so I have to subtract the smaller number from the bigger number. So the program here is written accordingly, such that bigger number comes above and smaller number comes down below. So as I showed you in the slide, the program is similar to earlier one, only there is a difference in line number 7, address number 2007, where instead of addition we have to subtract. So the code will be different. So now let's change that code in the address 2007. So for that I have to go to memory location 2007. And what is there? There it is written 80 because it was the code for addition. Now I have to change it to 90. So I am making it 90. So my program writing is over. Now I have to check whether I have entered all the codes properly. So for that I have to start from 2000. Then what is written here? 3A, right? Then 50, then 20, then 47, then 3A, then 51, then 20, then 90, then 32, then 52, then 20, then 76, right? So my program is properly written and I have entered the two numbers to be subtracted in the location 2050 and 2051. That also once again we'll check. So we'll go to memory location 2050 and what is there? There it is written 3A and 2051 it is written 8F. So now I have to execute the program and check whether I am getting the result in the memory location 2052. So for that I have to again reset, then I have to go for this key go, initial address 2000, then I have to say it is executed now. Now I have to check the result. What will be the result? Result will be 55. If I subtract 3A from 8F, the hexadecimal numbers 3A from 8F, then the result will be 55 and result is stored here in the memory location 2052. So now let's check what is there in the memory location 2052. So the result is there. So I am getting appropriate result 55. So my problem is solved for subtraction with the help of direct addressing mode. Let's go to the computer screen once again.
Again, we are back to the slideshow. Now we are going to write the third program. And this program has addition of numbers using indirect addressing mode. So earlier problem 1 and problem 2 was with the help of direct addressing mode. Now we are using the indirect addressing mode. This indirect addressing mode requires multiple memory references for searching an operand. It makes use of a comparatively larger space than the direct mode. Therefore, this particular addressing mode takes a little bit more time and it's little bit a slower process compared to the direct addressing mode. And here is the flowchart of how to solve a problem. So basic feature is we have to start somewhere with some initial data. Then here this part is interesting. This part, this is we have to take HL pair. The two registers H and L pair we have to use. That pair is used as a pointer. So first we have to initialize the HL pair to place the first number. Then we have to get the number in the register A. Then we have to increase the HL pair address by 1 to get the second number. And after getting the second number, we have to add the numbers. And finally, we have to store the result and finally end the program. And here is the example. So I have the addresses like before 2000, 2001, 2002 and corresponding hex codes 21, 50, 20 so on like before, and all the details are written here. Interesting thing is the HL pair. So LXIH is the new instruction, LXIH 2050H. So purpose of this instruction is a HL pair is used as a pointer for the address where first number is placed. In this case, the first address is 2050. Then the move as before. Then I have INX. INX is for increase of value of HL pair. Contents of HL pair is incremented here by 1. HL pair is pointing to the next memory address, in this case 2051. So the increment of HL pair is indicated by this command or this instruction INXH. Then like before we have to add and then we have to store the data. So during addition, add the contents of memory location whose address is in HL pair to the contents of A and store the result in A. And finally, for end the program, we have the instruction HLT and the corresponding hex code is 76. Now let's do the program writing in the trainer board.
Now I am going to show you how to write the program for addition using indirect addition method. Addition of two hexadecimal numbers using indirect addition method. Now the codes as I showed you in the slide. So now again I am going to start from the memory address 2000, but you can have memory address anything you want. You need not have to stick to the memory address 2000. Now let's see what is there, and I have to change the codes. So 2000, what is there? It is there 3A. Now I have to change. It should be 21, then 50, then 20, then it should be 7E. Alright, then it should be 23, then it should be 86, then it should be 32, then it should be 60, then it should be 20, then it should be 76, then next, then I have to reset, and I have to check whether 2050 and 2051 memory address has got the numbers 3 and 8F. So for that I have to check 2050. What is there? 3A. What is there in 2051? It is 8F. So properly saved. And once again I want to check whether all the codes are written properly. So I am starting from 2000 and check 21 right, 50, 20, 7E, 23, 86, 32, 60, 20, 76. Alright, now I have to execute the program as before. So for that I have to select go. Then I have to go to the initial address 2000. Then I have to press this full stop button fill. E means executed. So execution is over. Now I have to check whether I am getting the result at 2052 memory address, and that result should be C9 because this is the addition of two numbers 8F and 3A. Okay, then check. As said in the program, the memory location 2060 has the result. So result is stored in the memory location 2060. So I have to go to the memory location 2060. So what will be the result? Result will be C9. Let's see C9. So my problem is solved. Next, let's go back to the slide once again.
To write the program for subtraction of numbers using indirect addressing mode. And this is the flowchart for indirect addressing mode. So we have to start and then initialize HL pair to place the first number, get the first number in A, and increase HL pair by 1 to get the second number, then subtract the numbers, store the result, and end. And here is the program. It's similar to what I explained during addition. There is only one difference. This SUBM, it was earlier add M, now it is SUB. SUB means subtract the contents of the memory location whose address is in HL pair and from the contents of A and storing the result in A. Rest of the things are similar to as I showed you during the addition of two numbers. Now let's go to the trainer board to write the program, execute the program, and show the result.
Now we are going to write the program for subtraction of numbers using indirect addressing mode. As I showed you in the slide, there is a little difference with the addition of numbers using indirect addressing mode. Only the sub m, the corresponding code will change instead of add m. So let me check what is there in the memory location 2000. It was our starting address and it was 21, perfect, then 50, then 20, perfect, then 70, perfect, then 23, perfect. Here I have to change in 2005. Here it should be 96 instead of 86 because this is subtraction. So I have to change it to 96. Then next 32, right? Then 60, right? Then 20, right? Then 76, right? Okay, so the program is written. Now in this case again I have to consider the bigger one and smaller one. As 8F is bigger than 3A, so I have to put 2050 in the memory location 8F and 3A in the location 2051. So memory location 2050. I am putting, okay, what is there? There it is written 8F. Okay, so the next number is 3A. So now this program will subtract 3A from 8F. Okay, so now I have to execute the program. Program is, I have to give the initial address. Okay, now I have to execute. So it is executed. Now I have to check what is the result at the memory location 2060 and the result should be 55. So I am getting it correct. So the difference, subtraction in indirect addressing and subtraction in direct addressing, but in indirect addressing the position of smaller numbers should be adjusted carefully such that we always subtract the smaller number from the bigger number, otherwise the problem will be there. So we have to check once. Okay, so now let's get back to the slide once again. Now we'll learn the next problem.
Again we are back to the computer monitor. So our next problem will be writing the program for multiplication by repeated addition. And repeated addition, here is a schematic where we want to multiply 3 by 4. So the result will be 12. This 3 into 4 is equal to 12 can be represented as addition of 3 4 times. So 3 plus 3, again 3, again 3. Then we get 3 plus 3 plus 3 plus 3 is equal to 12. So this is the multiplication as repeated addition. And here is the flowchart to make you understand how the program should be written. So here is the start. Then we have to initialize HL pair to place the count. Use register A as counter and clear A to save the sum. Then we have to increase HL pair by 1 to get the next number. Then the sum will be earlier old sum plus next number. And then we have to decrease the count. And we have to check here, is count 0? If it is no, then we have to go back here in the loop and this will continue like this. But if the count is 0 and the answer is yes, the program will stop. So here a loop is active depending upon count. If count is 0, then it will stop. If the count is not 0, then it will go back to the old position. Then it will increase HL pair by 1 and do these 3 steps. And here is the program. So first part is the instruction LXI HL pair is used as a pointer for the address where first number is placed. Then second, move data from memory M whose address is in HL pair to register C. It copies basically the first number and determines the number of times addition will occur. Then MBI A00. So move 00 to A. Purpose of this instruction is to move 00 to A. Initialize A to 0 and initialize sum to 0. Then as before, it increases the contents of HL pair by 1. And now again HL pair is pointing to the next memory address, in this case 2051H, and the command is INXH. Then we have to add the two numbers. Then it will decrease the contents of register C by 1. So the command is DCRC. And another new command, new instruction is JNZ2007 loop. The purpose of this is to jump if the result is not 0. Content of C register not equal to 0, then it will jump to the location 2007. That means here. So it will again come back and add the numbers. So repeatedly it will add. Then if it is 0, then it will move forward and therefore the next STA2060, it stores the content of A in location 2060H, and finally it ends the program. One thing we have to remember, this part, it has 3 lengths 21, 50, 20. So this part is the memory address 2050 and this is the corresponding code for LXIH. 2050 is the memory address where the number is to be written. So let's do the program writing in the trainer board.
Okay, now we'll learn how to write the program to multiply two numbers by repeated addition. So in this case, as I showed you in the slide how to write the program. So now in this case I am taking two numbers 03 and 04, and that should be kept in the memory location 2050 and 2051. So first we will enter the two numbers to be multiplied. So the memory address 2050, there I am keeping number 03. Okay, next I am keeping the number 04. So my numbers are entered, numbers to be multiplied are entered. Now I have to write the program. So for program writing I have to go to the initial address once again 2000, and there it is 21. Alright, now it should be 50, then 20, then it should be 4E. So 4E, then it should be 3E, then it should be 00, then it should be 23, then it should be 86, then it should be 0D, then it should be C2, then it should be 07, then it should be 2 0, then it should be 3 2, then it should be 6 0, then it should be 2 0, then it should be 7 6. Okay, so program writing is over. I have to check whether I have entered the codes properly. So for that I am checking starting from 2000, 21, alright, 50, alright, 20 perfect, 4E perfect, 3E perfect, 00 perfect, 23 perfect, 86 perfect, 0D perfect, C2 perfect, 07 perfect, 20 perfect, 32 perfect, 60 perfect, 20 perfect, 76 perfect. Okay, now I have to execute the program. So I have to go to go, then I have to give the initial address, then I have to say this. So it is executed. Now I have to get the result. So result will come at memory address 2060, and what will be the result? Result will be 03 into 04 in hex. So that is 12 in decimal. So it will be in hex 0B. So let's try. What is there in 2060? So 0C, sorry, it should be 0C. So 0C is here. I am getting it. So I have got the perfect result of multiplication by repeated addition. Now let's go back to the slide once again.
Next problem we are going to solve is division by repeated subtraction. And here is the schematic presentation of division by subtraction. So suppose we want to subtract 20 by 4 and the result will be 5. But if we repeatedly subtract, like from 20 if I subtract 4 first, then we will get 16. From 16 if we subtract 4 again, then we will get 12. Then from 12 if we subtract 4, then we will get 8. Then from 8 if we subtract 4, then we will get 4. Then 4 minus 4 is equal to 0. So in 4 steps we are able to reach to finally 0. So here is a flowchart. So it's like before. I have to use the HL pair, and then here we have to check. If the count is 0, then it will stop, otherwise it will go back to the loop as I showed you earlier. And this is the corresponding program. So here, as before, I have explained all the instructions with the comments. You will be able to understand. So instead of addition, I am having subtraction here to subtract the contents of memory location whose address is in HL pair from the contents of A and store the result in A. And rest of the things are similar. So let's again go back to the trainer board to write this program, to execute the program and get the result.
Now I am going to show you the division by repeated subtraction. As I discussed in the slide, that I have to take two numbers and that I have to divide. So suppose I take numbers 12 and 3. I want to divide number 12 by 3. So the answer will be 4. So I have to first insert 12 and 3. 12 means 0C in hex and 3 means 03. So now let's see. 2050. I am entering the number to be divided. That number is 0C. 0C. Then next number will be 03. 03. And so this part is over. Now I have to write the program. So starting at this 2000, and then what should be entered? Let's see what is there. 21. It is perfect as I showed you in the slide. Then 50 is perfect. 20 is perfect. Then it should be 7E. So 7E. Then next it should be 06. 06. 06. Then next will be 00. Perfect. Then 23. Then then 04, 04. Then next will be 96, 96. Then next will be C2, right? 0720. Then it should be 78, 78. Then next will be 32. Then next will be 60. Then next will be 20. Then next will be 76. Okay. So I have entered the program. Now let's check whether I have entered them properly. One second. Okay. 215020 perfect. 7E perfect. 06 perfect. 00 perfect. 23 perfect. 04 perfect. 96 perfect. C2 perfect. 07 perfect. 20 perfect. 78 perfect. 32 perfect. 60 perfect. 20 perfect. 76 perfect. Okay. So I have written the program. Now I have to execute the program. So now I have to give the initial address. Then I have to press this. So it is executed. E means execution. Then I have to check. So the result will be at 2060 and the result here will be 4 means 04. Let's see what happens. 2060. So the result is 04. So I am getting the result, and you can try with your numbers and you can experiment in many ways. Your address, you can change the numbers to be added, subtracted or multiplied or divided, that you can select at your will, and all the codes are available in the manual and also in the textbook. So I hope you have learned. If you have any doubt, please send us email, and I hope you all have enjoyed my class and you all will be happy with this video, and we'll meet in the next video once again. Thank you for watching this video. Have a nice day.